Let's try another example. Let's try to solve the initial value problem y prime plus xy equals x, and this time we specify that y of 0 equals minus 6. Now this equation is already in standard form, so there's no rearranging to do as far as that's concerned. It's a first order linear differential equation, so our method is going to work here. The first thing is to find the integrating factor, and I of x is always going to be e to the integral of px dx, where px is the coefficient of the y term when the equation is in standard form. So in this case, ix is e to the power of the integral of x dx, and the integral of x is x squared over 2, so it's e to the x squared over 2. So let's multiply the standard equation by the integrating factor, which is e to the x squared over 2. We get e to the x squared over 2 dy dx plus e to the x squared over 2 times xy is equal to x times e to the x squared over 2 on the right-hand side. As always, the left-hand side compactifies. It becomes the derivative of the integrating factor times y. So it's the derivative of e to the x squared over 2 times y dx, and the right-hand side is now x times e to the x squared over 2. Integrating both sides with respect to x, we get the integral of the left-hand side equals the integral of the right-hand side, which is the integral of x times e to the x squared over 2. And the integral of the left-hand side is the easy one, because we're integrating a derivative. It's e to the x squared over 2 times y, and the integral of the right-hand side is the integral of x times e to the x squared over 2 dx plus that constant of integration. For the integral on the right-hand side, we can use a substitution. U equals x squared over 2. du is x times dx, so it becomes the integral of e to the u du, which is just e to the u, plus a constant, which is e to the x squared over 2. We have the left-hand side, which is e to the x squared over 2y, is equal to e to the x squared over 2 plus a constant. And now dividing across by e to the x squared over 2, we get y is equal to 1 plus c times e to the minus x squared over 2, or c over e to the x squared over 2. Now remember, we had an initial condition when x is 0, y is minus 6, so y of 0 equals minus 6. Plugging that into our equation, we get minus 6 is equal to 1 plus c times e to the 0, or 1 plus c is equal to minus 6. And this, of course, gives us that c is equal to minus 7, and y is 1 minus 7 times e to the minus x squared over 2.